Hi everyone, today we're going to be looking at solving a simultaneous equation using the substitution method. So we've got two equations here, and first step I'm going to label both of these. So over to the right hand side I'm just going to label this one as equation 1 and this one as equation 2, and that's a good habit to do all the time that you're looking at simultaneous equations. Next part, the idea of substitution is that we want to rearrange one of these equations and then substitute it into the other one. So if I have a look at equation 2 here, if I'm trying to get y by itself, all I need to do is add 2x to both sides. So I'm going to label my steps down here. I'm going to rearrange equation 2. So first step, rewrite the whole thing. Negative 2x plus y equals 9. And now I want to try and get y equals something. So I'm going to add 2x to both sides. So y equals 2x plus 9. Okay, we've rearranged equation 2. Now I'm going to substitute. So next step, that was step 1, this is step 2, sub equation 2, which for this is, I'm talking about that one right there, into equation 1. So anytime you see a y in equation 1, you're not going to write y, you're going to write 2x plus 9. So if I rewrite equation 1, I'm going to get 7x plus 10, and now instead of y, I'm going to put 2x plus 9. And then equals 36. Okay, now before we solve this, you can see I've got an equation here with only one variable or one letter. That's the idea. If you have managed to substitute it in and you've still got two different letters, you know you've done it wrong. So now we need to try and expand this out. So everything else stays the same. 7x stays the same. 10 times 2x is plus 20x. 10 times 9 is plus 90 equals 36. And next step, we're going to collect some like terms. So I'm going to have 7x plus 20x is 27x. And at the same time, I'm going to subtract 90 from both sides. So I'm going to have equals 36 minus 90 is negative 54. Now from here, I'm going to divide both sides by 27. So 27x divided by 27 just leaves x by itself. Negative 54 divided by a positive 27 is negative 2. Okay, we're about halfway done. Third step, we're going to sub x equals negative 2 into equation 1. And I'm choosing equation 1 again because in the second step I substituted everything into equation 1. So this time, anytime you see an x, you're going to put, instead of x, you're going to put negative 2. So I've got 7 outside of negative 2 plus 10y. This time we're not wanting to substitute 2x plus 9. We want to substitute y in so we can solve it down, and then we've got equals 36. Okay, again, check that you've only got one variable in your equation. That's how you know you've done it correctly. 7 times negative 2, negative 14, plus 10y equals 36. And now rearrange to get y by itself. So 36 plus 14 is 50. And on the left hand side we've just got 10y, and then divide both by 10, and we've got 50 divided by 10 is 5. So the solution occurs at the coordinate -2, which is my x value, and 5. Okay, now we're not quite done. Good practice means that we need to check this. So step 4, we're going to sub this coordinate when x is -2, y is 5 into equation 2. And I'm choosing equation 2 because up to this point I had been working with equation 1. So whatever equation you haven't been working with, it's good practice to substitute it into the other one. So anytime I see an x, I'm going to put -2. Anytime I see a y, I'm going to put 5. So -2 outside. Actually, how about I rewrite all of equation 2 to make it nice and simple. So right at the top we had -2x plus y equals 9. So I had -2x plus y equals 9. Let me just check that that's correct. Yep. Now from here I'm going to substitute it in so you can see what I'm doing. So -2 outside of x is actually -2 as well, so another -2 plus 5 equals 9. -2 times -2 is +4 plus 5 equals 9. 4 plus 5 does equal 9, so we're going to have 9 equals 9. Now the verification to this, left hand side equals right hand side, therefore, that's the symbol for therefore, solution of -2, 5 is verified. Okay, there you go.